HM Stars. How are you all students? Welcome to the maths class students. We were doing exercise 6.5 on Saturday. So today we will try to finish with this exercise 6.5.
Now question number 16 of your exercise 6.5 is find two positive numbers whose sum is 16 and the sum of whose cube is minimum. That means x cube plus y cube we have to make it as minimum, and the sum of the numbers, that is x plus y, if we are considering the other number as y, is equal to 16. So that means if my one number is x, the other number is 16 minus x. So my function Sx will become x cube plus 16 minus x whole cube. Now I have to minimize this. So as we proceed in the previous questions, first we will find out its first derivative and we will put its first derivative equal to 0. So here its first derivative is 6x plus 6 into with 16 minus x, and we are substituting it equal to 0. So we are getting the value of x as 8. Now we have to find its second order derivative and substituting the value as 8 in it. So we are getting the double order derivative as 96, which is greater than 0. So hence second order derivative is greater than 0. That means this is the point of local minima. So hence x equal to 8 comma x equal to 8 will be those two positive integers whose sum is 16 and the sum of whose cube is the minimum. Now next question number 17 is a square piece of tin of side 18 cm is to be made into a box without top by cutting square from each corner and folding up the flaps to form a box. What should be the side of the square to be cut off so that the volume of the box is the maximum possible? So here one thing is clear, that we have to make the volume of a cuboid to be the maximum, because you know a box is of the shape of a cuboid. Here we need to find its length, breadth and height to find its volume. So students, understand the question well, because understanding is more important in these questions than solving them. Yes, solving is also an aspect, but first we need to understand the question well, because rest of the part, once you are able to find the equation, rest of the part just repeats the same as we have done in the previous questions. First order derivative, sign of the second derivative, everything falls in the place if you understand the question well. So here understand this, first we need to find the length, breadth and height of our box. As we are cutting a square piece of edge x meters from each side, so this implies that from the length we are deducting 2x, from the breadth we are deducting the 2x, but its height will be x. So that means length is 18 minus 2x, breadth is 18 minus 2x and its height is x. So by this the volume of the cuboid will become x into width 18 minus 2x whole square, because its length is 18 minus 2x, breadth is 18 minus 2x, but its height is x. So if we consider the volume function as Vx, that becomes x into width 18 minus 2x whole square. Next we are going to find the first order derivative of Vx and substituting that equal to 0. First we are finding the first order derivative, that reduces to 18 minus 2x into 18 minus 6x. Next we are substituting that equal to 0. From here we will get x as 9 or 3. So our next step is to find the second order derivative, which comes out to be 24 into with 6 minus x. Next we have to maximize this. So we know that when we put x equal to 3, our value will become positive, that is second order derivative will become positive, but we need to prove it to be the maximum. That means second order derivative should be negative. So hence we are going to substitute x as 3. So answer will be minus 72. Hence, x equal to 3 is the point of maxima and the length of the square that is to be cut from each corner of the square piece. Now next, question number 18 is just similar to question number 17. Just try this question once, students.
That's all for today, students. Do revise what we have done in the class today. Plus do your homework also. And in case you have any query, please feel free to ask on the Google Classroom at any time. Take care and have a great day ahead, students.